Alright, so for problem number 4, we've got a new region. The sine, 2 times the square root of sine of x, which we graphs here. So that's going to be pi. And from this region, we don't have squares coming out of this base. So this is the base. It says perpendicular to the x-axis. We have triangles. Now what does it say? What kind of triangles do we have? Isosceles right triangle. Does it say anything about the base? The cross sections. Cross sections are isosceles right triangles along the x-axis. Yeah. Oh, look at it. All right. The real problem on the AP exam, they'll be more clear, because how do we know that the right angle is coming from here? Right? You could have had, we could have it. You have your triangle this way, where that's your right angle, I suppose. Anyways, so we have all these right triangles coming out of the smartboard like this. Okay. So what's the area that we're sliding now?
1/2 sine squared, or 1/2.
Base times, just let's say base times sine, right? Area of the triangle. So the volume is the integral from what to what? So it's a dx or dy integral? Dx integral of 1/2 base times height. Let's just write that now. It's good to just write that step, because now you've simplified the problem. Okay, I got to figure out the base, and I got to figure out the height. We're just breaking it down. We're not trying to do the whole thing all at once. Yeah, it's easier to do it one step at a time. So 0 to pi. I'll take the 1/2, put it on the outside. What's the base of this triangle?
2 sine of x. 2 root sine of x.
Yeah, it's our function. Now, how do we know how far out it's coming? Alright, it's right. So it's a right triangle, which means it's a 90-degree angle, and then so it's the height.
And base is the same.
The base and then the height are the same because it's isosceles, so it's just the exact same thing. If the right angled part was, you know, on the top, so like in other words, if we had this thing right here, or this was the right angle, we would have had a lot more work, because our base would have been 2 root sine of x, then half of that would have been this, then we would have had to figure out. Anyways, a lot more complicated. Don't worry about it. What did you say?
I know, I just said exactly.
Yeah, exactly.
Yeah, house play, right, Jimmy?
All
Child's play.
right. 1/2 cancels with one of the 2's. The square root of sine of x times the square root of sine of x is the sine of x. Alright, so what's the integral of the sine of x?
Cosine.
Negative cosine, right. So this is 2 times negative cosine of x from 0 to pi. What's the cosine of pi?
-1.
The cosine of 0 is 1, so it's 1 minus -1 because it's negative cosine. 4 units cubed. Is that an answer?
No, it's. Is it?
Yeah.
I got that. I changed my calculator. I got 2, but maybe that's wrong.
Do you have the both 2's?
I said 2 root sine of x squared. I might have closed
Did you
it.
square this 2 or just the sine of x?
I think I might have plugged it in wrong instead.
Yeah.
2.
I could have done something wrong as well.
Yeah, you're right. No, 4 is right. I had to print the seam machine.
That make sense? Any questions? On the AP exam, the cross sections are almost always perpendicular to the x-axis. In fact, every year from 2000 until 2009, until 2009, no, 2008, they're all perpendicular to the x-axis. So I told the student, everybody, all my students, I said, your cross-section problem will be perpendicular to the x-axis, so it'll be a dx integral, so don't worry about it. I just do it that way every time. And then that year, they had a cross-section that was perpendicular to the y-axis. And Danny drove it and never let me forget it. So he basically said that everything, the whole next year in calculus, he's like, how are we supposed to believe in this, Rouse? Everything you say is a lie.
Josh?
Sorry, Jimmy. I'm sorry, Danny. Yeah. So anyways, the point is that most likely it'll be perpendicular to the x-axis. But if it's perpendicular to the y-axis, that just means it's a dy integral, and you have to integrate that way. It's not that big a deal. It's just, we just have to practice that a couple times. All right, let's do problem number